I am Prasad from Structural Guide. You are welcome to the Structural Guide YouTube channel. Today we are going to discuss about consolidation settlement. What is consolidation settlement? We are going to have a detailed discussion on consolidation settlement. Today we will do a work example on the calculation of the consolidation settlement. Please subscribe our YouTube channel. You may get the notification on new videos. Let's discuss about the consolidation. This topic is somewhat boring, but I hope that you will remain in the seat and you will listen to this video, you will watch this video carefully and continuously. I have written down all the important things in this throughout this video in text format. You can read even later. So let's start. Consolidation. What's consolidation? Consolidation occur in the clay soils. When the application of additional load is there, the pore water pressure in the saturated clay increases. As the conductivity of the clay is very small, clay is a very impermeable soil, so permeability is very low. Then, when you apply a load, the pore water pressure will increase because pore water can't move very fast like other soils, so pore water pressure will increase. Sometimes is required the excess pore water pressure to dissipate and increase stress to be transferred to soil skeleton. So clay soil needs some time to transfer this increased pore water pressure to the soil, because rapidly when you apply the load, the water pressure will increase. Then the water can't move rapidly. With that pore water pressure increase, with the time this pore water pressure will reduce and the soil stress will pore water pressure or the stress in the water will transfer to the soil. This is what happen. This is happen gradually, and therefore it take some time. So this gradual increase in the effective stress in the clay layer will cause settlement over a period of time, and this phenomenon is referred to as the consolidation settlement. Application of load tend to volumetric compression underlying soil. When the soil is saturated, the pore water pressure increases immediately upon the application of the load. So I will discuss further what I explained previously. Consolidation is a process by which there is a reduction in the volume due to the expulsion of the water from the pores in the water. So the dissipation of the excess pore water pressure is accompanied by the increase in the effective stress and volumetric strain. Cohesive soil have much lower hydraulic conductivity, and as a result, consolidation required a longer time to complete. So consolidation will continue for longer time, as I explained. So once in a clay soil, once you apply the load, pore water pressure increases. With that, soil pressure won't be changing at that time, because of the water cannot dissipate very fast like other soils. With the time, pore water pressure will dissipate, then the clay soil stress will increase gradually. This process is called the consolidation settlement. We'll discuss this terminology in detail further. You will know what is the consolidation settlement further. Consolidation settlement. It's a time dependent process. It's a three-dimensional process as the water can move in any directions. But due to the confinement on the soil, the lateral movement is restrained. So therefore, mostly the consolidation settlements occur in the vertical direction. The permeability of the soil impact on the consolidation settlement. The permeability of the soil is one of the most important factor to be considered when we discuss in the consolidation settlement. Mainly, there are two stages in the consolidation settlement. Firstly, the primary consolidation settlement occur, then the secondary consolidation settlement occur. We'll discuss what are these in detail in coming slides. Before discussing about the consolidation settlement calculation method, we have to know the terminology. There are some terms that we need to know in relation to the consolidation settlement. First one is the primary consolidation. That is part of the consolidation settlement. There are two components, primary and secondary consolidation. What is the primary consolidation? The process of dissipation of increased pore water pressure due to the application of loads on the soil layer and increase in the effective stress in the soil skeleton. That's what I explained previously also. This is the primary consolidation. Settlement causes due to the reduction in the volume. So volume will reduce once the water will dissipate slowly, the volume will reduce, that causes settlement. Secondary consolidation. So there are two components in the consolidation. This is secondary consolidation. This occurs after the primary consolidation with the dissipation of the increased flow water pressure. This is secondary consolidation occurs after the primary consolidation. Occurs with the rearrangement of the soil skeleton, with the dissipation of the pore water pressure and with the reduction in the volume. So with the pore water pressure reduced, there will be rearrangement in the soil, clay soil. So this volumetric change causes the second consolidation settlement. This is also called the creep process. Right. Now we have discussed about what's the primary consolidation, then what's the secondary consolidation. Let's move on. Overconsolidation. Comparison of stress acting on the soil in the current stage to its highest stress experienced by soil. This may be somewhat difficult to understand. If I further explain this, if the current stress is less than the applied in the past, the soil is overconsolidation. What does this mean? So you can hear this is the present stage. Presently soil have no any loading, say no overburden on the clay layer. But in the past there was load. So there was a load in this clay layer. So past there was a overburden, presently there's no overburden. So that's what it means. The current stress less than the applied load in the past. You can see here, this part. Okay. Current stress less than the applied load in the past. Current stress less than the applied. These type of conditions we call the overconsolidation. So now you in the ground, say you have a clay layer. Now we don't have overburden, but in the past there was an overburden in this soil layer. Those type of soil is called the overconsolidation soil. We define overconsolidation ratio in relation to the overconsolidation. This OCR used to define the consolidation stage of the soil with respect to the past. Okay, so overconsolidation ratio equals highest stress experienced by the soil divided by the current stress on the soil. So with reference to the current stage, we compare the past. That is done by the overconsolidation ratio. It's work like factor of safety against the further consolidation. So further consolidation, if you have done, if you have if the soil is over consolidated, there is some benefits. So when the highest stress experienced by the soil is equal to current state, that means even past stays also same as the current state. Past when past there was a load in the soil, we say it's over consolidated. Even in the past, if there was no soil, and even past and today, if the condition are same, then we say the normally consolidated soil. So that's what we are going to discuss next. So we already know what is the normally consolidated soil. A soil that is currently experiencing its highest stress is said to be normally consolidated soil and has an OCR of 1. So overconsolidation ratio, what is mean by overconsolidation ratio? So highest stress experienced by the soil current state. So highest experience, if it highest stress experience is same as the present state, this ratio become 1. So present state and past previous state is same. So this ratio is equal to 1. So that type of soil is called the normally consolidated soil. Highest stress experienced by the soil equal to current status of soil. So the past stage and present stage same. The higher overburden pressure experienced by the soil remain the same as now. So that's also, in other words, we can say weight or stress applied by the other layers of the top. So now clay layer may not be at the top of the soil. Clay layer may be two layers below underground soil. So if the top layers won't change over the time, that soil is or normally consolidated. Okay. Now if top layers won't change over the clay layer, now clay may not be at the top level, no? So clay may be at the 3 meter below. So that level, from that level to ground surface, if these layers won't change over the time, then this clay is said to be normally consolidated. Preconsolidation pressure, one of the other term that is very useful in calculation the consolidation settlement. The maximum effective vertical overburden stress that particular soil sample has sustained in the past. Right? The pre-consolidation pressure is also expressed in other terms such as pre-consolidation stress, pre-compression stress, pre-compaction stress, preload stress. So pre-consolidation pressure. Now this is used in the structural design as an improvement for the foundation source. Now as we discussed previously, normally consolidated soil, the present and the past, the same condition is there. Overconsolidation means in the past we have a higher load, present we don't have that load. So that is overconsolidation. Now preconsolidation is something like that. So in the past, oh, the maximum effective vertical overburden that particular soil has existed in the past. So in the past, for some purpose like improving the ground, for cautious to reduce the settlement in the clay soil, we may do the preloading. So preloading, we do the preloading and then remove that particular soil and do the construction, the foundation and proceed. This can be done. So this kind of a preloading pressure or the previously applied pressure is called the preconsolidation pressure. Degree of consolidation. So let's discuss what the degree of consolidation. Degree of consolidation equals amount of consolidation at a given time with the soil mass divided by total amount of consolidation total amount of consolidation under the given stress condition. So that if I explain it further, the settlement of the clay layer at the time t after load is applied. So divided by the maximum consolidation settlement that clay layer undergo under given load. This is kind of a comparison. We at which stage we are in. This is kind of a comparison to the complete settlement to the present state. Say we are going to do a pre-consolidation. So we are going to apply a load on the clay layer as a measure to improvement the foundation improvement, ground improvement. So we apply overburden pressure on the clay layer. Then say we kept it 1 month. So at a 1 month we calculate the degree of consolidation. What's the degree of consolidation at the 1 month? Say it takes 6 months to completely settle the soil. So if it is take 6 months to it's complete the settlement, total settlement, to come to the total settlement. At a 1 month we measure the settlement, then it compare with the 6 month settlement. That is called the degree of consolidation. Soil types undergo settlement. What are the main soil types that subject to consolidation settlement? Clay soil, organic soil, silt soil. Mostly these are compressible soils. So these soils subject to the consolidation settlement. Primary consolidation. So we previously discussed consolidation have a two component. When you're going to calculate the settlement, we calculate these two components separately. First we calculate the primary consolidation, that's the one firstly occur. Then we calculate the secondary consolidation. That's what occur in the second. So primary consolidation, there are two stages. Normally consolidated soil, current state same as the past, right? Overconsolidated soil, the previously higher stress or higher load is applied than now. There may be two stages. When you can calculate the primary consolidation settlement, we have to consider these two stages, because this soil may have a normal stage even before you apply the load on the you even before we do the preloading. That soil is before preloading, its soil is normally consolidated. So when you put the load again, it's over consolidated. So likewise, this when you compare the present state, this soil behavior we have to consider, or this terminology we have to consider in calculating the settlement. Let's see how it's done. Now we are going to discuss about the calculation method of the settlement. So we discussed the terminology in relation to the consolidation settlement. What is the overconsolidation? What's the normal consolidation? What's the degree of consolidation? Overconsolidation ratio? All those now we have discussed. Now it's time to apply those. So how do we calculate the consolidation settlement? So we are now going to discuss about the consolidation settlement of normally consolidated soil. That is normally consolidated. That means the soil state present past are both same. No over consolidation. No loading over the soil until we load by the foundation. So here you can see the foundation is there, the no overloading or no over consolidation, the present and past is same. Only changes we have constructed the foundation, then foundation load is there. Consider a stress distribution under the foundation on the clay layer. So we are going to calculate the consolidation. So sand, there will be a immediate settlement, but clay layer there will be a consolidation settlement. So thickness of the clay layer we have said, see, so this is a clay layer. So we have to consider this stress distribution in the clay layer. Need to consider the average stress in the clay layer in settlement calculation. We have to consider the average stress in the clay layer. We'll see how we calculate the average stress later. The average increase in the pressure in the clay layer can be calculated as follows. So this equation can be used to calculate the average increase in the stress. So we have to calculate the average stress in the clay layer. In addition, we have to calculate the average stress increase. So average stress you calculate, also you calculate the average stress increase. So average stress increase we can calculate from this equation. So average stress increase at the top, at the middle you can calculate, then you have the bottom. So you take 1 upon 6 into the this value as the average stress. So once you calculate the average stress here, then now this chart, when you go to this chart, so this soil is normally consolidated soil. In this soil, the behavior with void ratios and the stress variation can be plotted like this. So if we from laboratory we can find the compression index. So with that we can have this chart plotted with the based on the soil parameters. So once you found these values, this is the slope or the compression index, we know the height, we can calculate the initial void ratio of the soil sample that's obtained from the laboratory. So the average stress in the soil we can calculate from the stress distribution. This average increase in the stress that can be calculated from this equation. So we know this. So this is also average stress in the soil. So these all we know, so we can calculate the primary constant settlement SC. So with that we can calculate. So it's look like that a simple process, but this is some kind of mathematical calculations are there. It's bit complicated when it comes to the calculation, though it's look like this. We'll see how to calculate the primary consolidation with the work example. Now, calculation to consider settlement of the overconsolidated soil. So this we know this is the normally considered settlement. So once this is the normal behavior of the soil. If the soil is overconsolidated, there will be another part here. This part will be added, right? This is due to the overconsolidation, right? So this is primary consolidation part, this is the overconsolidation part. So now we are going to calculate the settlement due to this foundation. So due to this foundation, now we are going to calculate the settlement. So there are two stages. That's clear to now. That is clear to us now. Sorry. Case 1. Applied stress is less than the pre-consolidation pressure. So pre-consolidation pressure, that's so applied stress is less than pre-consolidation pressure. So this is the pre-consolidation pressure. So you apply here the pre-consolidation pressure, this will settle like this. So then we have to consider this stage, right? Then applied stress is greater than the pre-consolidation pressure. So applied stress is greater than pre-consolidation pressure. That is, if you the soil is applies pre-consolidation, if we apply the pre-consolidation on the soil, there may be a different chart, because now naturally soil will behave like this. Now we have done the pre-consolidation, we have add the load, and then this soil is overconsolidated. Then on the overconsolidated soil we put the foundation. So depending on the applied pressure, now we have to calculate the settlement. If the applied pressure is less than pre-consolidated pressure, if it is in the normal consolidation level, we have to use this part. So there you have a different equation. So this is the stage, it's a pre-consolidation stress less than the applied pressure. So you can use this equation. This is what we can consider previously also. This equation. This is a primary consolidation. Same as that, because it is in the this stage before applying the pre-consolidation pressure, before we doing the overloading, before we doing the we apply the overburden to improve the foundation. We can use that. So case 2, applied stress greater than pre-consolidation stress. So this is the pre-consolidation stress. Normal consolidation stress, so you have the apply the load. So then if the applied pressure is greater than this one, so if it is in this stage, so this beyond this point, so beyond this point, right, there you have to use this equation to calculate the settlement. So depending on the stage and depending on the load, we have to find which part of the curve we have to consider for the settlement calculations. So this pre-consolidated soil, this chart we can calculate fine. So swelling index is there, so it's in with the soil swelling index you can plot the void ratios and swelling with, if you know this void ratio and swelling index, we can calculate the we can obtain this chart. So with that we can do these modifications calculations. So secondary consolidation settlement. So as we discussed previously, we discussed about two components, that's a secondary consolidation, primary consolidation. We previously discussed about the primary consolidation settlement calculations. Let's see what's the secondary consolidation settlement calculation method. The settlement cost due to the plastic adjustments of the soil fabric at the end of the primary consolidation is called the secondary consolidation. That's what we discussed. Secondary consolidation also can be explained as a seepage and reorientation of the soil particle under sustained load. The secondary consolidation we can calculate from this equation. Organic and highly compressible soils are more susceptible to the high secondary consolidation. This soil highly settled, they have a higher secondary consolidation settlement. The secondary consolidation is less significant in overconsolidated organic clay as the secondary compression index is very small. That's because when you have apply this loading, this plastic adjustments or restructuring of fabric could be minimal due to the we have done the preloading. So then this rearrangement may be less in these type of soils. Now let's see how we can do the calculation of the primary consolidation settlement on a normally consolidated soil. So we previously also we discussed about the settlement calculation in the normally consolidated soils. Okay, so normal consolidated soil. What's normal consolidated soil? We discussed previously. Let me go to that. Normally consolidated soil. So highest stress experienced by the soil is equal to current state. So there is no overconsolidation, right? Okay, there is no overconsolidation. So if it is overconsolidation, this method is different. But normal consolidated, no overburden is there, no preloading is there. Right. Let's come to the calculation. The work example. So you can see here the foundation pressure 160 kilonewtons per meter square pressure will be applied by the foundation. There are sand layers, groundwater table is there, clay layer is there 2 meter thick. So dry density are there, sand and the saturated density in the sand. So clay, dry density and the elastic modulus and the compression. Uh, this is the compression index also there, right? With that, let's start. How to calculate the settlement can be calculated from this equation as we discussed previously. So these parameters we have to find. SC is the consolidation settlement on the normal consolidation scale. CEC is the compression index to be evaluated from the laboratory testing, right? HC is the clay layer thickness that is known to us now. E is the initial void ratio of the clay to be obtained from the laboratory undisturbed sample. You get the undisturbed sample and you can find it at the laboratory. Sigma naught dash soil stress at the mid height of the soil layer. So that can be calculated. So clay layer is there. So mid height we can calculate the stress. So we can calculate as usual man. The average stress increase in the clay layer due to the foundation load. So average stress increase. Now this we know, this is now, this has to be calculated. That is average stress increase in the clay layer. We previously discussed about this. There is an equation. So with that we can calculate. But average stress increase in the top, middle and the bottom of the clay layer we have to calculate for that. So how to calculate the soil stress at the mid height of the clay layer? So we know the heights of each layer, so we can calculate that I think it's easily we can calculate. You can refer this. Calculate the stress increase in the soil at the mid height of the clay layer. So this is the equation we have to use for that. So we have to calculate the stress increase in these positions: top, bottom, middle of the clay layer. This is bit complicated, but now the book, the principle of foundation engineering, they have given simple method. Simple means in the sense they have simplified it, but there are there's a very complex equations are there, but they have simplified it to this. So with that we can calculate the this average stress. We'll see how it can be calculated. Change in the stress can be calculated from the Q naught into IC. Q naught is the pressure applied for the foundation. IC can be calculated from this equation. Here the M1 and N1 are there. So what is M1 and N1? M1 is LOB. LOB means foundation length and breadth ratio. N1 is depth divided by the half of the foundation width. So this depend on the depth. So these may vary depending on the position. So here and here and here, in these three positions depth will be vary. So with the change in this depth, we have to calculate n1. So each position you have to calculate the n1 here and here. M1 is constant, so we know the n1 each location. So with that we can calculate the IC at each location. So Q naught we know, say 150. E naught void ratio we know. So each location, so M1 we know it's constant, Z is vary, so 2 meter. So this, in the according to our example, we have to find it's given here. So here we have given 2 meter, 2.5, 3 meter. Likewise, depending on the height, you have to calculate that. So here you know depth. So Z is not from the the height. So n1 we depending on the height is Z over b by 2. So with that you can calculate the n1. From that you can calculate the IC. So ICQ is no, Q naught is IC you can calculate. If you consider Q naught as a 150, IC is there, so QIC you can calculate. So with that we can calculate the each location stress now we know. So these values we have calculated now. So with that 1 over 6 into add these three together and we can calculate the average stress. So if we calculate the average stress there, so we can calculate the settlement. So CC we know, HC we know, this is from the laboratory. HC we know the clay layer thickness. E naught from the laboratory we know. Sigma naught we calculated. Average stress increase we calculated. This one average stress in the soil layer, mid height clay layer we calculated. So settlement can be calculated like that. Settlement is 130 millimeter. So with that we can calculate the settlement of the normally consolidated soil. Similarly, the pre-consolidated soil also we can calculate settlement. We can calculate second settlement also similar manner, but not that simple as say. But you have to study on that, and you can do the calculation. So with that, we end today's discussion on consolidation settlement or the consolidation. Today we discuss about what is the consolidation and its terminology, its component like primary consolidation and secondary consolidation, the consolidation calculation methods, and we discussed about the work example too. So you may study this video again and again. So we have written the most useful informations there. So with that you will be able to understand the consolidation settlement better. Right. Thank you very much. So let's meet again from another video.